Hey fourthies, it's Miss Hubble. Today I wanted to do a little quick summary lesson on factoring. In your book, fourth graders, this is topic 7. This kind of summarizes lesson 1 and lesson 2. Okay, so we're going to do some factoring. Once upon a time, I taught you that factor times factor equals product. And we would multiply two numbers together and we get an answer or a product. We're kind of going backwards now. Okay, we're going to start with a number, and that number essentially is our product. So if I were to start with the number, say 8, and I would say, okay, well, what are factors of 8? Well, that would be any two numbers you can multiply together to get 8. So for example, I could do one factor is 2 and one factor is 4 because 2 times 4 is 8. So that's kind of what we're trying to do today. All right, we're going to be drawing arrays, which are like little shapes, rectangular shapes that show multiplication problems. And we're going to be, the other way we're going to show it is factor charts. Factor charts are also my super favorite way of finding all the factors of a number. Sometimes people will just list them. Sometimes people will do other things to find factors. I think a factor chart, you're not going to miss any if you use a factor chart. So it's super, super handy. Okay, so let's start with the number 6. We'll do the number 6, okay? And we're going to say, what are all the factors of number 6? When I go to factor something, I always start with the number 1. And the reason is because 1 is a factor of every number. 1 times 2 is 2. 1 times 10 is 10. 1 times 72 is 72. 1 goes into everything. And then I ask myself, 1 times what equals 6? 1 times 6 equals 6. The first factor, pair, or pair of factors for any number is always 1 times itself, right? So 1 times 6, and then I'm just going to make sure I don't miss any at all. I'm going to go on to the very next number. The very next number after 1 is 2, and I say, hey, self, does 2 go into 6? Well, I know it does because 6 is an even number. So I say 2 times what equals 6? 2 times 3 equals 6. This would be a good time for you to use that multiplication chart if you're still a little rusty on your multiplication facts. I could just go to the 2 row and I could follow my finger across until I get to 6, and then I could look up and say, oh, 2 times 3 is 6. That's how I could do that. Then after 2, what comes next? 3. Ding, 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 ding. 3 is already on this factor chart. The moment I get to a number that's already on the factor chart, I am done. These are all the factors of 6, okay? So we need to know a couple of terms. We need to know factor pairs and factors. So I'm going to say, well, how many factor pairs does 6 have? Well, a pair is like a pair of people or a pair of shoes. It's 2. So this is a factor pair, 2 numbers multiplied together. This is a factor pair, 2 numbers multiplied together. So this one actually has 1, 2, 2 factor pairs. Well, then you might ask, well, Ms. Hubble, okay, it's got 2 factor pairs, but how many factors does it have? How many different factors? And I would say, okay, let's check that out. I've got 1, I've got 2, I've got 3, I've got 4. Those are all the factors. So this one has 4 different factors, okay? So then my job would be to take what I've just learned, and it would be to put this into rectangular arrays, meaning every multiplication problem has a picture that you can draw to demonstrate it. So let me use a color here. I think that'll be helpful. I'm going to start by drawing 1 times 6. That means that it's going to be only one long, but it's going to be 6 wide. So I'm going to say 1, 2, 3, 4, 5, 6. So this right here, my friends, is a rectangle. It's a 1 times 6 rectangle. Let's do the next one. 2 times 3. This rectangle is going to look like this. It's going to look like 1, 2 long, right? 2 long, and it's going to be times 3. It's only going to be 3 wide. So that's 1, and that's 2, and that's 3. Well, let's look at this. This is a 2 times 3 rectangle. The 1 times 6 rectangle has 1, 2, 3, 4, 5, 6 blocks. Product is 6. And this one has 1, 2, 3, 4, 5, 6 blocks. Product of 6. Am I done? Is that all the arrays? Looks like it. No, that's not all the arrays. Okay, remember what we learned. there is a special property that says in a multiplication problem you can flip-flop the factors. Blake remembers that that's called the commutative property. Everett remembers that's also known as the flip-flop rule, okay? So we can flip-flop these problems and get 2 more arrays. If I took 1 times 6 and flip-flopped it, I'd get 6 times 1. All right, so let's do that. So this time it's going to be 6 long. 1, 2, 3, 4, 5, 6, but only 1 wide. So this is a 6 times 1 rectangle. It's the same rectangle. When you flip-flop a multiplication problem, you take the exact same shape, turn it on its side. That's it. Let's do the other one. We had 2 times 3 already. Let's flip-flop our our factors, and we'll get 3 times 2. So this time we're going to have, it's going to be 3 long, but only 2 wide. So our new rectangle is a 3 times 2 rectangle. Now I've got all the arrays there are. I've got 4 factors, 4 arrays, but it's only 2 factor pairs.